So we're going to start with some simple problems. We're going to look at a frictionless surface of ice. We have a book, and we're going to push it horizontally with a force of 1 Newton. So if I were to draw this picture, I have my book. We're going to end up talking about some other forces that are going on here. But the one that we're actually interested in is what's going on with this push. So we're given the force of the push, we're given the mass of our book, and we want to know what is the acceleration. So we learned that the acceleration is equal to the sum of the forces acting on our particular object divided by its mass. Well, in this particular case, because it's a frictionless surface, the only force that we're really interested in is the force of the push. That's that 1 Newton divided by that 2.8 kilogram mass. We can now get the fact that it has an acceleration of 0.36 meters per second squared. And I can know that is the unit because Newton, by definition, 1 Newton is equal to 1 kilograms times meters per second squared. And when I divide this term by kilograms, I'm left with meters per second squared, which is what that unit is. So that was my first sort of question. We can see that that's a pretty simple and straightforward one. With this next one, we're still looking at the same book, still have a mass of 2.8 kilograms, but we want to know the force now. Right? Well, we saw that force was equal to mass times acceleration. Well, we don't have this. We are told, however, that our book moves a distance of 0.8 meters. And it's starting from rest, which we know is 0 meters per second, and being accelerated to a speed of 5 meters per second. We can use this information to find the acceleration because we have equations from the kinematics unit we just did that dealt with that. If we look back, we saw that v squared was equal to v naught squared plus 2a x minus x naught. This does boil down to the delta x that I'm using here. Right? We know because this starts from rest, this is 0. When we rearrange the whole equation, we do get the fact that my acceleration was equal to v squared divided by 2 delta x. This term can now be substituted into our equation where acceleration is. So my force is equal to my mass of 2.8 kilograms times my acceleration, which is v squared, 5.0 meters per second, and that term is squared, divided by 2 times delta x, which is 0.08 meters. Okay, so remember, I plugged this into the force is equal to mass times acceleration equation, and I get 2.8 times. All right, so my program crashed on me, so we got to go ahead and sort of grab a couple things for a second. So we saw the fact that my force was equal to mass times acceleration. My acceleration is now that v squared over 2 delta x. We're going to plug those numbers in. So my force is equal to that 2.8 kilograms times that 5 meters per second, and that term is squared, and that's over my 2 times 0.8 meters. When I plug all that in, you should get something along the lines of 43.75 newtons. All right. If we go ahead and do round this to sig figs, this is going to be, my force is going to be 44 newtons. And that's how we get that one.